Hello everyone, my name is Raza and I'm a peer tutor at the Academic Support Center on the 9th floor UHD North 925. Today we will be talking about using the indefinite integral using a substitution method. It's pretty much the same as a power rule, but it's just that we use substitution method to break down more complex equations to make them much more easier and to work with. So let's go ahead and practice the problem. So let's just say if we have an integral of, let's say, x cubed plus 1 to the power of 8, right? So when you open that up to dx, okay, when we open that up, when you open the power up, the whole parentheses up right there, right, it's gonna take a lot of time to actually do like squared and the cube and then fourth power and stuff like that to open it all the way up. It's gonna make a really long complex problem. You can do it, but it's gonna take you forever to work with. So what we can do is we can take your x cubed plus 1 right there, right, and we can turn that into, let's call it u, right? So what that does is it's gonna make that whole thing right here change to u to the power of 8. Let me see, it's going to change it to, let's say, u to the power of 8. Let me take that off from there. Let's bring it here, right? So basically that's going to be u to the power of 8. Now, what we can do here is, now let's solve the u for a second. Let's see, it's going to be, let's say, du, and that would be, using the derivatives using the previous function, you can call it 3x squared dx. Right? Now, as we notice here, we only have an x squared. We do this so we can replace our dx as well, since we're changing u. Everything else, since we're changing our x for u, we have to change the dx for du as well. So what we can do is, we don't have the 3 here, right? What we can do is we can divide this function by 3 on both sides, right? Bringing the 3 over there. That will say our du, 1/3 of du is equal to x squared dx, right? Now we can say that this is equal to that. This function is equal to this right here. So what we can do is we can replace them. So that will make it into u to the 8th to the du times 1/3. And a 1/3 doesn't really make a difference. So what we can do is bring the 1/3 out. Say 1/3, right? Now, we changed this complex function right here into a much more simpler version to this. And we solve that up, we should get 1/3. We're going to have u to the 8 plus 1. As remember, the integration rule would be x to the n is equal to x to the n plus 1 over n plus 1. So what that's going to give us is, it's going to make into a 9 over 9. Right, let's multiply that and add a c next to it. Now, when we open that up, that can make it into a u to the 9th times 27 plus c. Now, we can't leave the answer as u since the question started with an x. So we're going to replace our u with our x cubed plus 1 and bring it in. It's going to call it x cubed plus 1 to the 9th over 27 plus c, and that would be your final answer. As you can see, we broke up a much more complex problem and made it into much simpler, and then bring it back to the complex problem when you found the final answer. So what that does is it saves us some time for opening it up into different sections. Now, let's try a different problem, because not all problems are going to be this straightforward. We won't always have a polynomial. We can also have trig functions. Now, when you work with trig functions, it's a whole different story. Technically, not really like a whole different story, but it gets a bit more complicated because you might need to know the integral of cosines and sines and work from there. As mentioned in one of the previous videos, it's always better to basically go over the table of the antiderivatives or integrals, and try to practice as many problems as you can to get to get used to them. So when the time comes to differentiate, you know what to work with. So let's try this problem right there. Let's say it's going to be integral of, let's say, square root of sine x plus 1 times cosine x plus dx. Right? Now, what we have here is it gets a bit more complicated, so you have square roots involved now too. Square roots are just like any other power, because instead of square root, we can just write, instead of root of x, we can just write x to the 1/2. And you can plug it in there, and you can use the same rule that we used earlier. But remember, for choosing our u value, right, we always pick the one that's inside a bracket instead of square root or something to make it much more simpler for us. Let's say sine x plus 1 right there. Right? Now what we can do is get the derivative of sine x plus 1, and that will be the derivative of sine is cosine x, and 1 is just 0, so it's going to be times dx. Now we have our cosine dx right here, so we didn't have to make any changes to our du, so we can just replace it. So that will make it into an integral of square root of u, square root of u times du. Now, as we said earlier, we can turn our square root into the power of half. That will make it into integral of u to the half times du, which we use the power rule again by adding 1's top and bottom. What we can do is it becomes a u to the 3 over 2 over 3 over 2, which eventually turns into 2u 3 over 2 over 3 plus c. Now we can replace our u with sine x plus 1 and bring it in. So that will make it into 2 over 3 sine x plus 1 to the 3 over 2 plus c. That's a problem for trig functions as well. So these are pretty much simple problems to work with. What can happen is you can have a much more difficult equation to work with, but then the only thing you need to know is that as long as you can identify the derivatives into the function, let's say here, see, sine x plus 1, the derivative of that would just be cosine anyway, so you know that you have to use that as a u. You have to use sine as a u, right? If you as long as you can tell the difference, and it's always safer to assume that your u will probably be inside a square root or bracket or anything that's complex enough, anything which has a higher power, right? If it's a polynomial, we always look for the one with the higher power in there. Let's say instead of, if you have an x cubed and x squared, I will always assume my x cubed to be my u, right? And then when we get the derivative of that, I should assume to get a 3x squared, which involves our x squared right there. Now, so that technically is all that we can talk about. And for U substitution, we are available in the Math Center from 8 a.m. to 8 p.m. or from Monday to Thursday, and 8 to 2 on Fridays, and 11 to 5 on Saturdays. So whenever you feel like to drop by, feel free. My name is Raza, and it'll be good to see you there. Thank you.